Okay, so we've learned how to add forces in one dimension. Now let's move on to the real tricky one with 2 dimensions. Okay, so this is now where all your vector skills will come in, right? So I'll give you, let's start with a first example. And this is a very real, very physical scenario, right? If we have a boat, let's say, that's my boat, looking from top down, and it's trying to sail forward. It has an engine, it has a driving force, okay, of, let's say, 10 newtons, okay. Pretty small driving force, but that's fine. And then it's on a river with some currents going this way. So the river is going to create a force pushing it sideways as well. Okay, so there's a pushing force by the current of 5 newtons, like that. Okay, and it's pushing it at 30 degrees angle. Okay, so now what is the overall force? What is the total force or net force or the resultant force in this case? Okay, so very physical scenario, you're aiming your engine forward, but there's some current pushing you towards this way. All right, so this time this is now you will see why it's called total force, because in one dimension you can sort of imagine which one subtract by which one, but here this is at an angle. So how do you deal with that? And the answer is this: you need to add up everything as a vector. So the net force is the driving force plus the current, okay, plus the pushing force by the current. It's always plus. If you keep this as a vector, it will always be plus. All right. In a second, we'll see how that's reconciled with why do we sometimes minus in the one dimension case. But in some sense, if you think about it this way, then it's even easier than doing it in one dimension, because it's always going to be adding it, but you need to add it with the vector sign, right? So just want to emphasize, this is what I commonly see. That would be wrong, right? That you're suggesting that it's the magnitude of this plus the magnitude of this is the total force. Just like with the first one-dimensional example, if I'm pushing 10 newtons this way and 5 newtons that way, the total force is not 15, it's only 5, because part of it is rendered useless, it's canceled out. There's only the total, the net effect, the resultant effect is only 5, right? And here, if you write this, that means you're just adding 10 to 5. And I've seen this many, many times. People would go like, oh, the net force is 15. That is far from the truth, right? Okay, so let's go back to the correct way, right? Okay, so what does this mean? So to add vectors, remember, there's 2 ways to do it. There's a geometric way and there's an algebraic way. And which one's easier? Usually the algebraic way. Okay, so we want to write this into its x and y components like this. Okay, I can also put this down, right? Like this. Okay, so now I just need to find out what dx and dy is and px and py is. Okay, so let's start with the easy one with dx. Well, this has 10 units this way and 0 units in the up and down. So I just have 10 units, and let's call this xy like this. So remember, whenever you do directions, always have a grid somewhere. So it's positive 10 because someone rebellious might define positive x going that way. I don't know why you want to do that, but you could. So it's always good to sketch that as well. So you will have positive 10 here and 0 in the y direction for dy. And how about px? Let's separately draw that out. After some experience, you probably can do it directly on here, but just want to be clear here, right? So there's 5 units this way, and it's making a 30-degree angle over here, right? So this is my p vector, essentially, right? So if you like, you can put in vector signs over here as well. That's even better. Sometimes people will be sloppy, so just be aware of that. What does that mean? So if this is the magnitude over here, let's say is P, right? The magnitude is 5. In fact, sorry, let me backtrack. I should not put a vector here, especially because if I put a vector sign here, I would expect 2 components, whereas there's only 1 component over here, right? This is a scalar. So here I'm telling you the magnitude is equal to 5, the magnitude is equal to 10, not the vector. All right, so yeah, the whole thing is a vector, but the magnitude is P. All right, so what is this side? Well, this side would be Px and this side would be Py, right? So I'm breaking it out. How many units of x and how many units of y, okay? And you can set up the equation now. I know P, so for example, sine, if I do sine 30 degrees, that would be Py, so opposite over hypotenuse, like this. What am I trying to find? I'm trying to find Py, right? I'm trying to find Px and Py. So Py is P times sine 30 degrees, and I do know P, right? P is the magnitude or the length of this vector. So 5 times, I know sine 30 is 1/2. I remember one of the famous angles, right? If you don't remember, that's okay. You have calculated it in exam, plug that in the calculator, make sure your calculator is in degrees mode. Yeah, so that will be 2.5 newtons, like that. As you know, I again put in my units at the very end, and only during the intermediate steps, you don't need to put in the units. It's a quick way of doing it. Okay, and then let's find Px as well. Px is that one. I can set up my sine cosines, but remember, I've also shown you a quick trick. Is if you notice, one of them is going to be sine, one of them is going to be cosine. Which one's which? Look at which one's sandwiching the angle, right? Px and P is sandwiching. So I know that Px will be the one with a cosine. So it's always P times cosine of that angle. Okay, so that's 5. And cosine 30 is the other famous one, which is √3/2. And you can plug that in the calculator. I don't have the number with me, but I'll just simplify that a little bit. In an exam, make sure you convert that to a decimal place and yeah, make to a decimal number. And then we will, you know what? In fact, let me do that. I'll be right back with you. Okay, let me pull out my calculator over here and let's actually do this out for completeness sake, right? So I have 2.5 times, what did I have? √3 square root of 3. So I have my scientific calculator over here. So it's 4.33, a long decimal, but let's just keep the first 2 decimal places. Usually that's good enough. We'll address significant figures and decimal places separately further down the road. At the moment, express everything in roughly 1 decimal place or 2 significant figures. That is fine. The general rule of thumb is whatever you're given with in the question, just use the same amount of significant figures. That's usually the rule of thumb in physics. Okay, so 4.30, in fact, let's double check if we actually use cosine, right? So if we use 5 times cosine of 30 degrees, and I have made sure I am in degrees already. So let's see, that makes no sense. Let's see, what did I do? And I'll check my mode. There we go. So make sure you are in degrees. It's a good lesson. I thought I did. Probably I restarted this. So cosine 30 degrees. All right, let's see. There we go. Okay, so we have the exact same answer. Let's say 4.3. All right, I'll switch it back. Okay, good. So we have 4.3. Let's do 4.33 with 2 decimal places, just in case, since it's still an intermediate step. All right, so are we done? Because it's not done, right? I need to fill in the blanks over here. So Px is 4.33 and Py is 2.5, okay? All right, so is this right? Okay. I haven't, this is not completely right yet. I've made a small mistake. Can you spot it? It's not a mistake, but it's just not yet done. Let's always double check the signs. Should this be positive or negative? If you look at this, well, Px, what's P? P is going in the positive x direction, but then the negative y direction. If you look over there as well, you see that y is going downwards, not upwards. So it should be that should be positive, that should be negative. So that's fine, but the other one should be negative. All right. So now you add these. It's very easy to add. Okay, so just add the top column, top row, sorry, together, which is 14.33, and the bottom 0 plus minus 2.5 is minus 2.5. All right, and this is our F net. Okay, let me emphasize that again. With a vector, it has components. Okay, without a vector, it has magnitude. All right, so that's close. All right, let's put in back the units. I can put it outside because anything outside just multiplies straight in, so that's fine. All right, but is that the final answer? Still not quite, because we asked the magnitude and direction, right? That's usually what we asked. If you ask to find the net force, you need to find both the magnitude and direction. How do you get it from here? Well, we've learned that skill already, right? So let's go with magnitude, right? Magnitude is, let's just, yeah, it's always good, even before you delve into that, it's just sketch this out a little bit. First of all, for doing the directions, it's almost, you must do it. And secondly, it just gives you a quick check and see if it's intuitively correct. So let's think, right? So let's draw out the coordinates, x, y. So this would be 14 something unit this way, and then minus 2.5 this way. Okay, so this is, so it's 14.33 this way and minus 2.5 this way. So this is my F net. Okay, so it's pointing in this direction. Okay, so before I go with the magnitude and direction, let's see, does that make sense? You can try to put this geometrically together as well. So I need to do a tip to tail or head to tail method, right? Create a triangle. So I'll move this P vector all the way, right? Parallelly, I'll move it all the way over here, right? Almost the same, right? So move that over here. So this is now my P, and then the resultant vector is going to be this, okay? That, right? Let me write that here. Okay, so that the thicker line one is F net. Does that look right? That's the thickest one, looks something like 14 units this way and minus 2.5 this way? It looks pretty good to me. I'm not quite sure with the 2.5, but at least horizontally, it went more than 10, right? So it looks pretty accurate to me. So there's two purposes for doing a quick sketch out, is to, number one, get a quick sanity check if that looks right. Because if you have forgotten this sign, for example, if you have done plus, you will get a positive over here, right? 0 plus that. And once you draw it out, it doesn't make sense, because otherwise what you get will be something going upwards. Whereas if you draw out this geometric addition over here, you'll get something that goes downwards like this. Okay. And the second purpose is to find magnitude and direction for sketching this out, because now the Pythagorean theorem is very, very obvious over here, right? The magnitude of F net is just 14.33 squared plus 2.5 squared. It could be minus 2.5 squared, but if you square it, they're the same, right? So you do the Pythagorean theorem over there. Let's do this together for completeness. So I have, let's do this all together, right? So square root of 1.3, oops, sorry, that's not what I want. Square root of 14.33 squared plus 2.5 squared, enter, right? So that's 14.54. So this is my final answer, and I can put it in one decimal place, which will be 14.5. Okay, so we'll put that here, 14.5. And now this is my final answer, so I'll put the units back as well, and the direction, as you have learned how to do, right? So let's find this angle. We're gonna express it as the amount of angle downwards from the positive x direction. This length over here, even though it's going down, the length itself is 2.5. The length over here is 14, right? So tangent theta is 2.5 over 14.33, right? So theta is arctangent of this. And again, let's plug this into our calculator, our trusty calculator. We have shift tangent. So we have this arctangent or inverse tangent thing. And I want 2.5 divided by 14.33. Okay. So I get 9.89. So let's round that to 9.9 degrees. Just as a double check, let me go to mode and double check I am in degrees. So that's a good thing. All right, so let's go back over here, 9.9 degrees. Okay, and should we stop there or do we need more information? We need more information, right? Otherwise, people don't know 9.9 from where, right? So it's going downwards, so you can say downwards from the positive x direction, or let's say you can use clockwise or counterclockwise. That's also a good way. So I will say clockwise from the positive x direction. All right, positive x axis. Okay, good. All right, so this is going through step by step how this works. Let's see a couple of more examples, and I'll sort of speed it up and see once you get familiarity how it will work. And you'll see sort of the method on how to do this.